Let's understand what logging means and why we should implement logging in our applications. And also, we will talk about logging in Python. Logging is a very useful tool in a programmer's toolbox. It can help you develop a better understanding of the flow of a program and discover scenarios that you might not even have thought of while developing. Logs provide developers with an extra set of eyes that are constantly looking at the flow that an application is going through. They can store information like which user or IP accessed the application. If an error occurs, then they can provide more insights than a stack trace by telling you what the state of the program was before it arrived at the line of code where the error occurred. By logging useful data from the right places, you can not only debug errors easily, but also use the data to analyze the performance of the application to plan for scaling or look at usage patterns to plan for marketing. This can make the process of decision-making easier for the management. Imagine you are running a Python script and you want to know what part of the script was executed, at what time, and in certain cases, inspect what values the variables hold. Usually, you may just print out meaningful messages so you can see them in the console. And this probably is all you need when you are developing small programs. The problem is, when you use this approach on larger projects containing many modules, you want a more structured, robust approach. But why? Because the code could go through different stages such as in development, debugging, review, testing, or goes into production. You want to see different level of details in the printed messages. The type of messages you want to print out during development or debugging can be very different from what you want to see once it goes into production. Depending on the purpose, you want the code to print out different types of messages. Imagine doing all these things with only if, else, and print statements. Besides, there is a certain level of hierarchy needed in printed messages, and this thing makes the entire process much time-consuming and inconvenient. So here's the logging comes into the place. The Python standard library comes with a logging module that provides most of the basic logging features. By setting it up correctly, a log message can bring a lot of useful information about when and where the log is fired, as well as the log context, such as the running process or thread. Before getting our hands dirty with the code, we must understand some concepts that are often encountered in the logging module. The first thing is logs level. Logging has 5 different hierarchical levels of logs that a given logger may be configured to. Each level has been assigned its numeric value. First one is debug. These are used to give detailed information, typically of interest only when diagnosing problems, and its numeric value is 10. Second one is info. These are used to confirm that things are working as expected, and its numeric value is 20. Third one is warning. These are used as an indication that something unexpected happened, or indicative of some problems in the near future, and its numeric value is 30. Next one is error. This tells that due to a more serious problem, the software has not been able to perform some function, and its numeric value is 40. And the last one is critical. This tells a serious error, indicating that the problem itself may be unable to continue running the program, and its numeric value is 50. Despite all of them, there's another log level we don't usually talk about, and that's not set. By default, a new logger has the not set level, and as the root logger has a warn level. Its numeric value is 0. Great. The second concept we should understand is the logging formatting. The log formatter basically enriches a log messages by adding context information to it. It can be useful to know when the log is sent, where, means, Python file, line number, method, etc., and additional context such as threads and process, which can be extremely useful when debugging a multi-threaded application. You can see an example of a log formatter, where we have date and time at the first place, the name of the log and its level, then function name and line number, and finally the log message. So when a log hello world is sent through this log formatter, it will become something like this one. The next concept is logging handler. The log handler is the component that effectively writes or displays a log. For example, display it in the console, maybe using stream handler, in a file using file handler, or even by sending you an email using SMTP handler. Each log handler has two important fields: a formatter which adds context information to a log, and a log level that filters out logs whose levels are inferior. So a log handler with the info level will not handle the debug logs. Great. I think that's enough for this clip. In the next clip, we're going to explore the Flask debug toolbar. Thanks for watching.